All right, hey everybody, welcome back. We're all about getting curious and asking those big questions like, how does all this stuff even work?
And today, we are diving into the world of physics.
Yes, we are.
With some of the most brilliant minds who helped us understand
Like how things move.
why they move that way.
It's a lot more exciting than it sounds, trust me.
Yeah, you've probably heard of some of these big names like
Newton, Einstein,
But we're also going to introduce you to some,
maybe lesser known.
but equally amazing physicists who changed the game
So buckle up, because
Yeah.
we're about to take a wild ride.
through the history of physics.
Okay, so first up, let's talk about something that we all experience every single day.
Gravity.
Yeah, why do things fall down and not up?
Well, that's where our good friend Isaac Newton comes in,
Oh yeah, Newton with his famous laws of motion.
which you've probably heard about in school.
But we're going to break it down.
In a way that's
Hopefully a little bit more fun
a little bit more relatable.
than just like memorizing formulas
Yeah, because these laws are actually happening all around us.
all the time. Right.
Exactly.
So like, give us an example.
Okay, so let's start with Newton's first law, which is all about inertia.
Inertia. Okay.
So imagine you're playing a game of soccer.
Okay.
You kick the ball.
Right.
It doesn't just stop in midair, right?
Right. It keeps going.
It keeps moving until something stops it.
Like another player.
Or the goalpost.
Friction.
Yeah, exactly.
So it's like the ball just wants to keep doing its thing
Exactly. It wants to stay in motion.
unless something forces it to change.
And that brings us to Newton's second law, which is all about force and acceleration.
Okay. So the harder you kick the ball.
The faster it's going to go.
So, okay. Makes sense.
And then we have Newton's third law, which is
The favorite one.
for every action.
Equal and opposite reaction.
Yes.
Okay. So back to our soccer example.
Okay.
When that ball hits the net.
It exerts a force on the net,
Right.
and the net pushes back with an equal force.
Okay. And that's why it like,
Swings back.
yeah, it doesn't just like stay there.
Exactly.
I always wondered about that.
It's all about that push and pull.
Okay, so we've tackled how objects move here on Earth.
But what about out there in space?
Yeah, the planets and stars and all that.
Well, that's where folks like Galileo and Kepler come in.
Okay, so Galileo, he was kind of a rebel, right?
Yeah, he was a total rock star. He challenged all these old ideas.
So back then, everyone thought heavier objects fell faster.
Then lighter objects, right.
Right. But he actually tested it.
Yeah, there's this famous story about him dropping balls of different sizes.
From the Leaning Tower of Pisa.
And guess what? They all landed.
At the same time.
Exactly, which proved that gravity affects all objects equally.
Wow, so he didn't just like guess
No, he actually did experiments,
to figure it out.
which is kind of the foundation of,
The scientific method.
exactly, observe, hypothesize, experiment.
Okay, so Galileo helped us understand how gravity works here.
And then Johannes Kepler.
Yeah, what about him?
He took this knowledge even further by figuring out the laws of planetary motion.
Oh, so like how the planets move around the sun?
Exactly. And before Kepler, everyone thought that planets moved in perfect circles.
Okay.
But through careful observation and some serious math skills,
He discovered that they actually move in ellipses.
yeah, which are kind of like stretched out circles.
Okay, that's pretty
It
mind-blowing.
was a revolutionary discovery.
Okay, so fast forward a little bit.
To maybe the most famous physicist of all time.
Albert Einstein.
I mean, the hair alone makes him iconic.
I know, right? But
Yeah.
seriously, what's the deal with his theory of relativity?
Well, Einstein realized that time and space,
Are not absolute.
they're relative.
So like, what does that even mean?
Okay, imagine you're on a train moving really fast.
Okay.
To you, it feels like you're standing still.
Yeah.
But to someone standing outside,
You're zooming by.
exactly. And this difference in perspective actually affects how we perceive time and space.
That's wild. So it's not just like some abstract concept.
No, it has real-world implications.
Like what?
Well, think about GPS satellites.
Okay.
They have to adjust their clocks to account for relativity.
Otherwise.
Our directions would be way off.
Okay, so Einstein's theory, it's not just like some crazy idea.
It actually affects our daily lives.
That's incredible.
And speaking of crazy ideas,
There's that famous equation.
which basically means that energy and mass are interchangeable.
So like you can turn matter into energy.
In a way, yes, a tiny amount of mass can release an enormous amount of energy.
Okay, like a nuclear bomb.
Exactly, or the sun.
So the sun is basically converting mass into energy,
All the time.
which gives us light and heat.
It's the ultimate power source.
This is blowing my mind.
It's pretty awesome, right?
Okay, so we've talked about some of the big names, but there are so many other amazing physicists who deserve a shout out.
Totally, like James Joule.
Oh yeah, what did he do?
He figured out the connection between heat and mechanical work.
So like if you rub your hands together?
They get warm because you're converting that motion into heat energy.
Oh, wow. I never thought about it like that.
And then there's Michael Faraday.
Faraday, he was the one with electricity, right?
Yeah, he discovered electromagnetic induction,
Which is A.
a fancy way of saying he figured out how to create electricity using magnets.
Wait, so like our generators and motors?
Are all thanks to Faraday's discoveries?
So basically we wouldn't have electricity without him.
Pretty much.
That's huge.
It revolutionized the world.
Okay, and what about Robert Hooke? What was he all about?
Hooke was fascinated by how things stretch and bounce back.
Like elasticity.
Exactly. He was the one who figured out that the more you stretch something,
The more force it takes.
and that force is stored as potential energy.
Like a stretched rubber band.
Or a compressed spring.
Okay, I'm starting to see a pattern here. All these seemingly separate discoveries,
Are actually all connected.
they're all pieces of the same puzzle.
And to add another piece to that puzzle, let's talk about Leonhard Euler and Daniel Bernoulli.
Who were they?
They were pioneers in the world of fluid dynamics.
Okay, so that's the study of,
How liquids and gases flow.
so like water moving through pipes.
Or air flowing over an airplane wing.
Okay, that sounds pretty complex.
It is, but their work is essential for understanding all sorts of things.
Like,
How to design airplanes.
Okay.
How to predict weather patterns.
and even how blood flows through our body.
Exactly, so fluid dynamics.
It's basically physics in motion.
You got it.
And speaking of motion, we can't forget about Ernst Mach,
Ah, yes, Mach. He was obsessed with inertia.
which is,
That idea that objects want to keep doing what they're doing.
so like a ball rolling will keep rolling unless something stops it.
Exactly. And his work on inertia was actually a huge influence on Einstein.
Wow, it's like all these physicists were building on each other's ideas.
Across centuries.
It's pretty amazing when you think about it.
It's like a giant relay race of scientific discovery.
Okay, and to bring us to the finish line, we have Richard Feynman.
Feynman, one of the most brilliant and quirky physicists of the 20th century.
I know, I've heard his lectures are legendary.
He had this incredible way of explaining complex ideas.
In a way that was both funny and insightful.
Exactly, and his main area of expertise was quantum electrodynamics.
Okay, I'm gonna need you to break that down for me.
Well, it's basically the study of how light and matter interact at the tiniest levels.
So like atoms and photons.
Yeah, think of it as the instruction manual for how electrons talk to photons.
Okay, that's a pretty cool analogy.
It's a mind-bogglingly complex subject.
But Feynman helped make it.
A little bit more understandable.
Wow, so we've gone from Newton's laws of motion to the strange world of quantum mechanics.
It's been quite a journey.
It really has. I feel like I've learned so much.
Me too. And the cool thing about physics is that there's always more to discover.
Yeah, it's like this endless exploration of the universe and how it works.
And who knows, maybe some of you listening out there will be the next great physicists.
Making groundbreaking discoveries that change the world.
It's all about staying curious and never stop asking questions.
Yeah, like we did today.
So thanks for joining us on this deep dive into the world of physics.
We hope you learned something new and had a little bit of fun along the way.
And until next time, keep exploring.
Keep wondering and keep those physics questions coming.
Because the universe is full of mysteries waiting to be unraveled.
And who knows, maybe you'll be the one to unlock them.
So get out there and do some physics.
All right, that's it for today's show. Thanks for listening, everybody.
See ya.